Excellent. Cool. So, Mike, we were chatting last week because I do lots of ice baths, I do lots of exercise. Christmas is coming up, and I think there's a lot of people that will be taking a lot of drugs because that's what happens at this time of year, in particular cocaine. And I started to get really paranoid that I was getting addicted to ice baths because of the dopamine, the dopaminergic effect, and how I felt amazing when I did them. And then I hadn't done them for a few days, and I was starting to feel down and low. And I was thinking, is this happening? Am I getting addicted to an ice bath the way people can get addicted to a drug? And then I kind of panically sent you a voice note, which you responded very kindly to. So I thought it would be good to share.
Mm. Yeah, I mean, it's a fair question. And I mean, if there's any inkling of neuroscience about a podcast or a video or anything these days, everybody's talking about dopamine, right? Everybody loves to talk about dopamine. And the
Dopamine
fact
hit.
is, yeah, the dopamine hit. And the fact is, dopamine's involved in everything you do, right? Pretty much anything that involves self stimulation, moving forward with anything, motivation, reward, achievement, stuff that makes you survive, all involves dopamine. I mean, it's absolutely widespread in your brain. So, you know, it's technically not untrue to say that dopamine's involved in issue X because it just is. But like most things you and I talk about, it's all about the detail. So we have a very well constructed reward mechanism in our brain that, number one, helps us to feel satisfaction when we do things that are good for us. So it's the thirst quenching drink or the orgasm with sex, all that kind of thing that makes you feel really good. And that involves dopamine. And you have dopaminergic networks in this reward system. You have the ventral tegmental area connects into the nucleus accumbens, and the former drives dopamine into the latter when you get something that you want to be essentially rewarded. And the nucleus accumbens uses dopamine then to feel that reward that you feel. Right, that's a natural process. It happens all the time. It's happening every day, and it's absolutely normal and natural. As well as that, in this network, you bring in limbic system areas like the hippocampus and the amygdala, which help us to feel the emotions around it and help us to bed it down in memory, because you want to be able to remember how you did it, because it's good for survival. As well as that, then the final brain area is this kind of frontal region, so you can sort of think logically about it, but that's a sort of for another day. So you've got this really well-honed, intricate, exceptionally sensitive reward system that you activate all the time. And things like ice baths and all the things that have this kind of contradictory effect on us can stimulate this reward network. And that's all natural and fine. And it's a fair worry to say, oh gosh, am I doing too much of this, or am I doing something that's too addictive? And then you've got a whole sort of complex question about psychological versus physiological dependence and addiction, whatever. But the question then is, gosh, if I'm doing too much of this, is this kind of like cocaine, or I'm going to have this big withdrawal and whatever?
Exactly.
So we understand. So I mean, let's understand how the actual the drug dopamine works, or the neurotransmitter, or how any neurotransmitter works. So ultimately, you have a nerve cell that delivers the drug into a gap, and then you have a nerve cell that picks it up to take the message, as it were. And it's like a lock and key. And the presynaptic, or the before the gap brain cell, gushes the dopamine into the gap, right? So it just releases it into this huge space, like all these keys. And that's picked up in the postsynaptic cell after the gap by receptors. And those receptors are activated by the drug, by the dopamine that goes into the gap. And the magnitude of the effect on the postsynaptic cell is in part driven by how much of this receptor is in the gap. But it's mainly driven by the number of receptors, or the number of locks that you can open on the postsynaptic cell. And what happens is, and this is again, it's quite typical, of any synaptic communication is you get the release of it from the stimulation of the presynaptic neuron. You get release into the synaptic gap, activation of the receptors, and then some process, and it varies, by which your body sweeps up all of the drug and takes it away so it can stop having its effect. It can break it down variously. It can draw it back up into the presynaptic neuron. It can send transporter vesicles out to pull it back again. It sequesters it in some way and takes it back, and the effect stops. And that's great. And then you have the effect and things move on. That can be excitatory or inhibitory. In other words, in the membrane that is being affected, that can be an excitation or inhibition. And remember, this postsynaptic neuron or nerve cell or whatever can have millions of inputs. So you kind of got all of these competing inputs. So we can get this sort of idea of complexity. That's a natural, normal process. And your body responds to more or less dopamine by changing some of the physiology. But that's again for another day. What happens with things like cocaine, and the reason that, we were kind of looking for reassurances, if I'm doing an ice bath every day, yeah, okay, right, there might be some issues related to, doing too many ice baths and to the dopaminergic effects of that.
Are they issues to me getting frostbite? Are they issues to the dopamine network or the dopaminergic effect?
Well, I mean, it's kind of like doing anything that's overstimulating any network in your brain, right? It's going to have some sort of an impact. But when we were talking, it was about the magnitude, the worry that you would have this kind of cocaine withdrawal.
Yeah, it was like if I didn't do it on day X, my whole day could be negative, or I could fall into a negative thought pattern because I didn't get that high or the hit that everyone talks about. And I was like, am I just replacing, one vice for another? But this is the one that everyone says is really good for you, and it's good for your mental health, and it's good for your brown fat, and all these various health benefits. And I'm going, but anything that's that good, often there's a counterbalance, or is there?
I mean, it's like anything else that's rewarding, right? That anything else that would be considered to be kind of in the normal gambit of day-to-day activity. It follows the same principles that you keep doing it, and then you don't do it, you're going to have some sort of withdrawal from it. I mean, that might be physiological, but it might also be psychological, or often just a combination of both. The big difference, and this is sort of where we centered our conversation, the big difference was in that worry about the magnitude of the effect. Yeah. And that's where the mechanism is really important, because you have the use of the same neural networks, but with cocaine and any other, like your thirst quenching drink. What's different is that a drug like cocaine hijacks that and puts it on overdrive. And the mechanism by which it does that is it stimulates this reward network, which is fine. It causes the release of dopamine into that gap, as we, in the same way as your ice bath or your nice drink or whatever on a hot day. The difference with cocaine is it prevents its reuptake. So it prevents the destruction, for instance, or the reabsorption of dopamine from that gap. So what happens? You have this constant overstimulated postsynaptic neuron, you constantly overstimulated reward center. So you get this massive rush, this massive feeling of pleasure. And it's almost instantaneous, because cocaine is readily absorbed into your bloodstream. And of course, that relatively easily explains the high that people experience. The downside, of course, is that the magnitude of the effect then, on the one hand, I mean, with long-term use, can drive genetic changes in terms of genetic expression of these receptors. But ultimately, what your brain is going to do is say, we've got this overstimulation pattern. So your brain responds then by saying, either responds directly and says we need to reduce the number of receptors on the postsynaptic membrane, or you ultimately burn out its capacity to keep producing dopamine. The net effect being, you keep doing this,
And just to be really clear, we're talking about cocaine use at the moment as opposed to ice baths.
Yeah, because what you're doing with cocaine is you're introducing an exogenous agent to influence this endogenous system. So this is not a natural thing. I mean, it's natural
Yeah.
insofar as it's made of molecules and atoms, but it's not your kind of run of the mill system for which we are generally built.
We're introducing an external stimulus that is pharmaceutical, or essentially we're introducing a drug into the system instead of an action or behavior, that type of thing. There's
Exactly.
an external.
And it's the magnitude of it. It's the extent to which you can do a lot of very potent things very quickly. That's why it feels so good. But your brain responds then either passively, I mean, something happens to it, or your brain responds actively, in that with the ultimate goal of you becoming less sensitive to your endogenous dopamine. So you get this dip that accompanies cocaine use. So you get this dip down. And that, as I say, can be the depletion of dopamine or the reduced sensitivity or reduced number of postsynaptic dopamine receptors. So you can't get the same stimulation. And then you eventually come back to a level.
So if I'm an understand, I always like to simplify it. So it's almost like the brain has got all these, let's call them keys or locks or opportunities to fill a space with dopamine. And when there is overstimulation, it starts closing some of those doors and says, no, we're overstimulated. So instead of having 100, you can have 50 or 20 or ultimately very few, or alternatively, it just is unable to create the compound which forms dopamine. But one way or the other, your brain is going to reduce that stimulation when you use an exogenous source.
That's right. And you can think then about, we go back to what we talked about at the beginning. What kind of behaviors does this reward or drive network push? I mean, it pushes sort of it controls behaviors which drive us forward. It controls motivation, the seeking for things, and there is that apathy, that down that comes after cocaine use, when all of those networks are blunted. So you get that kind of blunted psychological feeling. One thing that's also important to mention is this network, this kind of system that we're using here, is evident in worms. It's evident in some of our more basic sort of physiological systems that it coexist with us, which takes us back about 2 billion years in evolution. So this is, you are talking, I mean, because you think about it, I mean, it has every organism has to have some drive forward to achieve things, to get things done, even if that's at its most basic, pushing your genes down the line or eating to stay alive. When you understand that concept, you understand the power that these kinds of systems have over our behavior, because it is fundamentally wired into the very basis of what it is to be a human being. And to give you a sense of how strong that is, there's lots of laboratory evidence to show that if you give laboratory mice or rats the choice between cocaine and food, they'll go for the cocaine, and they'll ignore the food, and they'll do that till they starve.
There was a really interesting study on that, though. I feel like it was Jonathan Haidt, but it could have been someone else, that talked about if you put a rat in a cage and you give it cocaine on one side and food on the other, it will starve to death by overtaking the cocaine. But if you put that same rat into what he referred to as rat Disneyland, and it has lots of other rats and games and wheels and this whole kind of play area, actually the rat will stop taking the cocaine, because they will get it, they'll see some sense, as it were. There'll be a small number that get addicted, but most of the rats will actually go about their life in this rat Disney world, because they have the social aspects and they have the connection. And yeah, I think his book was called Lost Connections. That's what he was talking about, this rise of opioids and drug use across the US, because you've got towns where people have no purpose or no meaning or no friendships or no families or whatever, in the extreme. And it was a really interesting evolution of that study, I thought.
And again, I mean, this is ultimately what, the evolution of social science is all about. It's understanding the complexity. These things don't happen in a vacuum. You know, we are social beings who live in a really complex environment. That's really important. And then on the other hand, is something I mentioned at the beginning, is part of this whole system is the frontal and prefrontal cortex, the executive decision maker that you have out here. And that becomes blunted as addiction takes hold. And so your capacity to regulate yourself becomes diminished. So this idea of people should know better is just nonsense, because it's knowledge is not power in this context. It's much more complicated than that. So it's not like the person who is taking a drug to excess or smoking or whatever it is. It's not like they don't know. It's not about knowledge. It's a complex neurological basis that sits within a complex biopsychosocial context. And that's how you understand it. And of course, that's not simple. And we love simplicity.
Yeah, it's almost like you want to be able, people that have never suffered from addiction will always say, well, it's their own fault or whatever. But if you say to them, well,
because that's easy.
Yeah, but if you say to them, well, actually, parts of their brain have been closed by that drug. So even though they know in one element this is wrong and it's bad for them, the control mechanism, and I'm just making this up, has been reduced. So they're no longer able to say no. And you see it when you meet someone that's addicted to anything, and it could be, meet people addicted to running, and their bodies are falling apart, but they have to go and run. It's just an addiction, and it's kind of, as you say, it's that closing down of the thought and the more cognitive, rational part of the brain.
Yeah, and we have to accept that, and you have to understand that, and you have to sort of that's what makes it's very easy to try and simplify these kinds of things, but the fact is that they're complex behaviors that sit in a complex neurological and social environment. And that, I'm sorry to say, means that the solution is complex, and it's multifactorial, and it's layered across society and education, and how we think and how we teach our children, and how we set up our societies, and how we set up our welfare systems, and how we set up our support systems, and how we develop culture. And that's also influenced by how and where we house people. And so I'm sorry to say,
what does this have to do with my ice baths?
You keep
we're trying to change the world now. Wait a second.
You keep hopping into the bath. I think you're safe enough.
So let's go back to that maybe to finish off. So if we do a direct comparison between taking an external source like cocaine, or engaging in an ice bath every day, or something like that, exercise, like intense exercise, I guess would be similarly, people get addicted to that exercise high, or running or whatever. What's the fundamental difference between the drug and the behavior or the ice bath? Let's just keep with the ice bath for simplicity.
It's ultimately some behavioral mechanism by which you take charge of your reward network, and you work it hard, right? It's like eating chocolate. It's the same thing. You're just driving that reward network, versus introducing an exogenous agent, which completely and utterly fundamentally shifts the mechanics of how that thing works, to put it onto overdrive, which fundamentally then changes how it works and becomes an unsustainable activation of that network, which comes with the inevitable withdrawal at the end of it.
Okay, so it's, what were the two words that you used when we spoke? It's exogenous or endogenous?
Endogenous, yeah.
Which is self-create. How would you define endogenous, just for comparison?
Endogenous is your own internal stuff. Exogenous is coming in from the outside. Got you.
And then this completely, hopefully linked, but random thought came into my head. When people have these, you hear these stories of someone who's walking across the road and they nearly get hit by a truck, and they have this almost, this close to death experience, and then they experience this huge high where sometimes time slows down, sometimes they run really far, but often this huge emotional high, maybe it's relief, I don't know what it would be. Is that in any way linked? Is there a huge overstimulation of networks when that happens, or is it just a different thing altogether?
I mean, it's a complicated sort of phenomenon. You have the fight or flight, that very basic limbic driven activation of the sympathetic nervous system that comes with the whatever that intense stimulus is. That's quick. That's the classic fight, flight, or freeze, with the activation of the sympathetic nervous system and the release of catecholamines and all those things that drive on behaviors. But what typically tends to happen after that, and of course that makes you active, and it wakes you up, and it does all those things. What typically tends to come as our body tries to achieve homeostasis is you get an acute activation of the parasympathetic nervous system to try and drag that down. And that's why people then often feel faint or sick, or have to lie down or whatever afterwards. Is you just get this very strong compensatory parasympathetic activation. I mean, certainly dopamine has a role in that, but fundamentally it's there's a crossover, but it's in some ways a different thing.
Maybe something to talk about another time, because it makes me think about when I've done mountain climbing, or I meet people that are into these extreme sports, and they become completely addicted to that feeling. And that's got to be wrapped up in a lot of this. There's the fight or flight for sure. There's the feeling of getting close to death, and then the recovery, or it's not recovery, it's survival. And then how that makes you feel amazing.
It's reinforcement. It's behavioral reinforcement.
Then they always have the low, post the expedition, post the parachute jump, whatever it is, you have this extreme low, which is that constant, it feels like there's a constant striving in your body for homeostasis, like getting back to normality. And there has to be a low to get back to an even, essentially. Like what goes up must come down, and vice versa.
Maybe,
yeah. Possibly too simplified, though.
Yeah. Like what you're moving on to now is sort of, you have to talk not only about the neuroscience of it, but the behavior analysis of it, essentially, the behaviorism that goes with the seeking of behaviors like that.
Cool. Well, let's pause it for there, because we're going to go off into the topic. But I've written down a few things I think we can talk about again. So there's drive, fight, flight, freeze. I think that's really an interesting topic. And then this last point around, thrill seeking. Which again, it could be an interesting one. All right, we'll leave it there for today. Cool, sounds good.
Sure.
So I'm allowed to have my ice bath, just to be clear.
You go and have an ice bath, and I'll see you in an hour.
Just no cocaine in ice baths. Right, okay, got it.